So recent experiences have got me a lot more comfortable with the idea of posting stuff on YouTube. So I thought I would do a few quick videos on various pieces of lab equipment. And these are all pieces of equipment that are kind of relevance to DNA sequencing or DNA sequencing industry. So some of you might recognize this, but it might not be as recognizable as it was in its original form. This is the optical system, or the major component parts of the Solexa, then Illumina genome analyzer slash genome analyzer 2, because they are basically the same instrument as I understand it. There was if I remember, a camera upgrade, and the flow cell was changed slightly. Not the flow cell, the flow cell and the jig that the flow cell sits in was slightly modified to allow a larger region of the flow cell to be imaged. So this is the optical block on the left. Then you've got stage controller. I have it rigged up to a mini PC here, which I use it with. It's kind of a bit of a mess right now, to be honest. This isn't the original objective. This is a different objective I've been playing with. And there's usually, well, I have the original one over here. There's a laser system that couples in to the main system. I actually have a different laser, higher power laser set up on this platform at the moment. But you can see the fiber comes out of the laser and heads in to the optical system, where it's fired through this. I forget what they call it. It's like a focusing module. Is it collimating? I'm not exactly sure if it's collimating or not, but it's basically producing a beam on this end through this multi-mode fiber that heads into this prism, which is just sitting. There's a little lever, and this has been bashed around a bit. There's this prism, so it fires into the edge of this prism, goes through the prism, hits the top surface, and then bounces out the other side where it's collected. So that the idea is that creates like a surface field, an exponentially decaying field on the surface of the prism. So you confine the optical power near the surface of a prism or anything that's kind of coupled onto it. So they use let me see, they use a special optical matching, I think it's this one. This mentioned in the Genome Analyzer 2 manuals, but basically this is optical matching fluid, which is specifically designed for fused silica. So the refraction index is matched to what must be a fused silica prism, and the flow cell, I assume, in these instruments was made out of fused silica, which is a bit more expensive. But it's that material is used because it's low autofluorescence, which means if you kind of shine a laser through it, I guess normal glass has some tendency to autofluoresce, so it emits different frequencies of light, which would interfere with creating noise, essentially background noise. So yeah, low fused silica for low autofluorescence. So that means you can image molecules near the surface, right, without any of the background from the bulk of the fluid in the flow cell. And you might ask, well, why is that? why are we doing that? Why do we care about the signal from the bulk of the fluid? Well, main reason is because Solexa was originally discussed about, it's public information to this effect, a single molecule company. So they were doing single molecule imaging, I imagine, on rigs very similar to this. So like prism style TIRF, which is what this system is called, TIRF, this total internal refraction system, which produces this field near the surface, is a way of cutting down the background noise when you're doing single molecule imaging. Now it's not so popular. People in academic labs tend to use what's called objective style TIRF. So the laser actually goes through the objective, bounces off, the objective lens to create the field there. So yeah. So that's the kind of that part of the optical system. And it heads up into a tube lens, which this is an infinity objective microscope essentially. The objective is on a mount to allow focusing, which is controlled by the same motion controller as the stage. You've got actually there's a mirror here where the focusing laser would come in through the back of the instrument, bounce down onto the surface and allow autofocusing. But there's also an tube lens in there. I think it's in here. Yeah, it's in here. To focus your light. Was it? No, I'm not sure. Maybe it's up here, isn't it? I'm not sure. No, this it must be up here actually. So to focus it onto the image sensor. In between, you've got a filter wheel, which again controlled by the same motion controller as everything else. Well, I use these cheap cameras which kind of sit on the top. I've got the other one. I think. Well, you can kind of rig it up so it works. Nice thing about all this stuff is it's fairly standard, so you can use Micromanager to control all of the stages. So you've got, you can get these, you can get old genome analyzers for like $50 if you hunt around. So you get like a infinity microscope with an automated stage, a 532 nanometer laser, 500 milliwatt laser, and another one. Is it 660? Am I remembering that right? Someone will tell me. 660, yeah, probably. In addition to that, the laser usually goes through a mode scrambler, which is, believe it or not, a speaker with some fiber wrapped around it. that's what a mode scrambler is. It's a like a hi-fi speaker kind of thing with some fiber wrapped around it. I have some pictures, which I'll link below, but it's basically wiggles the fiber around to kind of spread out any structure in the beam, I guess. But it does make, when you're capturing images, it makes it much flatter and more consistent. You do have to, they have kind of vibration isolation on them. You have to be, this isn't even enough. You have to be really careful with vibration isolation. I stick a pile of Kim wipes under it actually, and that otherwise the vibration from this will get coupled into the rest of the system, and your images are all kind of horrible and wobbly. So yeah, this is the second one, and I have another one in a box actually, with a different objective here, but this is the original setup. So this is wired into the original lasers here. The reason I've got two lasers here is I left it for 6 months and the laser just tried to power it up and the laser died. I bought another whole genome analyzer off eBay, and the laser was low power in that. It's like 200 milliwatts or something, which is not really great for me. So I might need to buy another one, which is very sad. I might actually just get a laser, but they're like £5 grand, so I don't want to buy that right now. So yeah, I use various for checking output power, because you're going to lose quite a bit of power. This is multi-mode 5, I guess you lose quite a bit of power. I have one of these field best meters that you get on eBay for, I don't know exactly, but I remember them being cheap compared with the 4Lab stuff. 4Lab stuff is a few grand, I think, and I think these are like $100 or $200. But I did buy a 4Lab meter as well, if I can find it. Yeah, I kind of compared. I have another post comparing performance of this against a used 4Lab meter, and it's looks like it's pretty much spot on, or at least good enough for my purposes. So yeah, I kind of recommend these cheap ones. I kind of personally, because I buy a lot of junk, it's nice to have multiple meters, so you can compare the meters against each other to at least know you're probably in the right ballpark. So yeah, but then yeah, it's the same basic system. This is a prism that I had custom made from AliExpress. I think they ended up being about 20 quid each or something, in quantity 10, something like that. But you've got the same filter wheel, everything else. Is there anything else to talk about relating to the Genome Analyzer? We've got various other bits of it lying around. We've got this would be the fluidics system, which I've never used, but I understand is controllable. Just put it on this thing. Yeah. These original objectives, which I think, if I remember, are 20x objectives that will have these lovely labels on them. The mode scramblers come with a surprising variety of branding for what is, as I say, a speaker with some fibre wrapped around it. It's this Illumina one, point source. One of those. Yeah, what else have we got? Yeah, that's fine. It's I think this is the controller, SBS controller. I think there's a STM32, if I remember one of these. I can't read it right. Oh, it's definitely an ARM. I think this is an STM32. Got an Altera, FPGA, I presume, some power stuff. The craziest, one of the craziest things about this instrument, if I it's just here, if I can find it. Is, yeah, that's fine. That's also fine. Is the everything is interconnected through RS232. So you've got this, I forget what they're called, Edge something. Edge Networks? Inside Out Networks, it says on here. I remember Edge Port, something like that. But basically there's this company that makes these things with like tons of serial ports on them. And they're just USB connected. I think the USB port, if I remember, there's like a hub. There's a D-Link hub, a commercial grade D-Link hub, which a couple of things plug into, and then that just feeds out the back of the instrument. And then like you can just plug this into a computer, and yeah, you've got you'll come up with 8 COM ports on Windows. So that controls a lot of the random stuff, like the chiller. There's a chiller knocking around. And obviously the stage and the lasers are all controlled from this by a regular PC. If you look at pictures of a Genome Analyzer, it's like a nightmare. I mean, it's basically just a bunch of lab equipment that's wired together in a box, and and shipped. So I forget that, you know, I was trying to, I remember trying to count the number of mains power supplies that sits in the instrument, but there's like 5 or 6. There's one for the camera, obviously this stage controller has one built in. There's another one for, I think, each of the lasers. Not sure about that. I think there was another one for the mode scrambler. There's just like all of these like mains voltage power cables that are wrapped up in the instrument. It's kind of scary actually, but it worked, you know. It was a lab rig that got tidied up and shipped, I guess. So it's kind of cool. Maybe another day we'll talk about the Ion Torrent PGM. What is it I have to say? Like and subscribe. And then I'll do that, or I won't do it if you don't do that. So there you go.